Johnny, start the slides. Johnny, we went over this. We're starting. Good. Okay. My grandma used to tell me, 2 plus 2 equals 4, unless you're into tax evasion. Hi, I'm Jacob Williams, and I'm here to teach you about the properties of logarithms in Chapter 7.4. To review, I can't see. A logarithm is a quantity representing the power to which a fixed number must be raised to produce a given number. Warning. This lesson is 7.4, and therefore it is not my job to teach what logarithms are. I am here to teach about the properties of logarithms. So let's get to the point. For the properties and formulas, when b does not equal 1, the following applies. The product property shows how to add logs. When 2 logs are added, the values of m and n are multiplied. The quotient property shows how to subtract logs. When one log is subtracted by another, they are divided. For the value being subtracted, m becomes the numerator, and the subtracting value, or n, becomes the denominator. Seeing that logarithms were first discovered in 1614, it saddens me to think that for so many centuries, loggers were unable to add and subtract their logs. I am sad. The power property just shows that the coefficient of a log and the exponent of a log are interchangeable. And also here are the equations switched if you wanted to see that. I don't actually know where it is, so. The equation down here somewhere, I can't actually see where it is, but you can see it, so that's sweet. The equation down here tells you how you can simplify a logarithm to get to a reasonably usable number. I understand that this is hard to understand without many examples, so here we go. In simplifying using the quotient property, remember that m becomes the numerator and n becomes the denominator. When simplifying the fraction, simplify the anti-logarithm so that it appears as the base number to a certain exponent, and then cancel out the bases to get the answer, which is the exponent. This is a simple demonstration of the power property, where 6 times log base 2 of x is transformed into log base of x to the power of 6. We can then apply that concept in the next demonstration using the product property. Remember that m and n must be multiplied in adding logarithms. Coefficients 6 and 5 are in the way, so they must first be simplified into their exponent forms. Then, the values can be added to generate log base 2 of x to the power of 6 times y to the power of 5. And if you're irritated that there are no boxed answers, well, here you go. Anyways, expanding a logarithm can be more difficult to figure out. In this example, we need to expand log base 3 of 250 over 37. Seeing that we are given a fraction, we can first use the quotient property to reverse it. Log base 3 of 250 is still too large, so we can use the product property to further divide into log base 3 of 2 and log base 3 of 125. Because of the power property, we can turn our exponent of 3 into a coefficient of 3. Since the exponents are now gone, we are at the maximum state of expansion. So, log base 3 of 250 over 37 expanded equals log base 3 of 2 plus 3 times log base 3 of 5 minus log base 3 of 37. Now it is time to test out the change of base formula. First you take one apple, and then you take a second apple, and then you throw those apples away. Because we're doing big kid math, and we don't need apples. Now, let us see if we can turn our log base 8 of 16 into a practical number. If you forgot, this should help you figure out how to set up your equation. The first goal is to figure out the common base of 16 and 8. The common base will be 2, because 2 to the power of 3 is 8, and 2 to the power of 4 is 16. Because it is now a fraction, log of base 2 is able to be cancelled out, giving us 16 over 8. which is able to be then simplified further into 4 over 3. This is an example of logarithmic scale from the textbook because I'm too lazy to create my own word problems. Anyways, to be fast, I will generalize how to solve this problem. We are given the use of negative log, so we can write the equation. Our total is actually a difference of 2 logs, so write them in. After the equation setup is complete, plug in the values. Log of 6.3 times 10 to the negative third can be separated, and because the other 2 logs are base 10, they are able to cancel out and become their exponents. And bing bada boom, that's it. If you do not understand this lesson, rewatch the video at a slower speed. If the video can't help you, ask a friend. If your friend can't help you, ask the teacher. If the teacher can't help you, well, God bless your pointy little head.